In this video, we're going to talk about factoring by grouping. Factoring by grouping is a method that we use when the polynomial that we are trying to factor has four terms. Look at something like this. xy minus xz plus 7y minus 7z. As you can see here, we've got four terms in this polynomial. So this will be a good one to try factoring by grouping on. And when we factor by grouping, what we're going to do is we're going to group the first two terms together and the last two terms together. And we're kind of look at these as two separate problems. In this first group, we're looking for the greatest common factor of that group. We're going to factor out the greatest common factor. So for those two terms, their greatest common factor is x. So I'm factoring out an x just from these two terms. That's going to leave me with y minus z. On my second group, only looking at these two terms, you're looking for their greatest common factor. In this case, it's going to be a positive 7, so we write plus 7, and that's going to leave me with y minus z here. Now, if factoring by grouping is working, then what you see here in these parentheses should match what you see in these. Now, that's not to say that it will always work, but if the polynomial is going to factor by grouping, these are going to have to match. So if they don't match, you might want to double check your work just to make sure you didn't make a mistake. Now that you're here, you're looking at this group and this group and saying, what do these have in common? A greatest common factor. And they have a binomial greatest common factor of y minus z in common. So I can factor out a y minus z from this first group, that's going to leave an x, and from this second group, that's going to leave a plus 7. And so this is my final factored answer, y minus z times x plus 7. Now, if we wanted to check that, we could multiply these two binomials back together using FOIL or the distributive property. I'm going to take the y and I'm going to distribute it through the second set of parentheses. Y times x. You can put yx. I just like to put my letters in alphabetical order. xy. Y times 7 is 7y. Then I'm going to come back and distribute my negative z. Negative z times x is negative xz, and negative z times 7 is negative 7z. And if you look, we have the same four terms that we had here. They're not in the same order, but that does not matter. So this is correct. We have the xy, we have the positive 7y, we have minus xz, and minus 7z. So this is the correct factored form of this polynomial. All right, let's look at another one. What if we have 8a squared minus 4ab plus 6ac minus 3bc? All right, we are going to group because we have four terms. So when we have four terms, we're always going to attempt factoring by grouping. We're going to look for the greatest common factor in the first group. Okay, for 4 and 8, those are both divisible by 4. You also have an a in both terms, so we're going to be able to factor out a 4a, which is going to leave 2a minus b. Now remember, you can always double check by distributing that back out in your head and making sure you get this. All right, in my second group, 6 and 3, the largest number that I can take out of those would be a positive 3. Those also both have a c, so I'm going to factor out a 3c. That's going to leave me with 2a. And then for my second term, when I factor out a 3c, it's going to leave me with minus b. All right, now this is how we know we're doing well. We're on the right track. Our parentheses match. So we have that common binomial that we're going to factor out a 2a minus b. Out of this first group, that will leave a 4a. Out of this second group, when I take out 2a minus b, it'll leave plus 3c. And this is my answer. If we wanted to check it, we would distribute, FOIL that out, and we should get these same 4 terms. Okay. What about 8w to the 5th minus 10w cubed plus 12w squared minus 15. Okay, once again, when we see we have 4 terms, we're going to group the first 2 and the last 2. We're going to look for a greatest common factor for the first 2. For 8 and 10, I think the greatest common factor is going to be 2. And then for my w's, the most I can take out is w to the 3rd. That's going to leave me with 4w squared minus 5. Okay, remember, these exponents have to add up to this, because when I multiply this back out, I would add my exponents. 3 plus 2 is 5. 2 times 4 is 8. W cubed times w squared is w to the 5th. And then when we distribute that, that would give us 10w cubed. All right, in my second group, I can factor out a 3. I can't factor out any w's because the last term doesn't have any w's, and it has to be something they have in common. So 3 is all I'm going to be able to factor out there. That's going to leave me with 4w squared minus 5. Again, that's good. We know we're on the right track. We have the same binomial here and here. So we're going to factor out that binomial. And from the first group, that would leave 2w cubed. And from the last group, that would leave plus 3. And again, you could check that if you wanted to. Okay, now we are going to do, let's see, a cubed minus 3a squared plus a minus 3. Okay, once again, we have 4 terms, so we're going to group. In our first group, we have an a squared in common that we can factor out as our greatest common factor. That's going to leave a minus 3. Now, when we take a look at our second group, you might say, well, I don't see a greatest common factor. Well, this is where it's important to realize that all terms can have a greatest common factor, even if it is just 1. And when you're factoring by grouping, you have to factor something out of each group. So if you don't have anything else that you can factor out, or no other greatest common factor that you can see, you can always factor out a positive 1, or if you need to, a negative 1. In this case, we're just going to factor out a positive 1 because this first term is positive. Factoring out a positive 1 won't really change anything. It's like dividing both of these terms by 1. So this will leave us with an a minus 3, which matches over here, so that's a good sign. We're going to factor out that a minus 3, which will leave us with a squared plus 1. Okay, now let's look at this. C cubed plus 3c squared minus 4c minus 12. All right, 4 terms, so we're going to group. We're going to look at our first group. We're going to look for the greatest common factor. I see that these both have a c squared at least, so I can take out a c squared. That's going to leave me with c plus 3. Now, we haven't run into this yet on any of these problems, but anytime the first term in a group is negative, then you want to factor out a negative GCF. So when you look at 4c and 12 and you think, well, I know these are both divisible by 4, and I want to factor out a 4. Yes, but you want to factor out a negative 4 because this first term is negative. So anytime this first term is negative, we're going to factor out a negative of whatever we're factoring out. So a negative 4, that's going to leave c plus 3, because when you divide by negative 4, negative 12 divided by negative 4 is positive 3. So when you factor out a negative, it's going to change your signs. All right, now I'm going to factor out a c plus 3, which is going to leave me with a c squared minus 4. Now, we have not learned how to do this yet, but this one can actually factor further. This is called the difference of squares. I'm not going to do it in this video, but if you want to watch my difference of squares video, it will explain how to factor this piece of the polynomial a little bit further. But for now, I'm going to leave it like that. Let's see. How about y cubed plus 8y squared minus y minus 8. All right, once again, I'm going to group because I have 4 terms. I'm going to look for my greatest common factor in my first group. That's going to be y squared, which is going to leave me with y plus 8. Now in my second group, it is similar to this one that we did, and that when we first look at it, we might think, oh, I don't have a greatest common factor for these, but I want you to remember that you can always factor out a 1 or a negative 1. In this case, we want to factor out a negative 1 because the first term is negative. In factoring out a negative 1, this will become positive y, and this will become positive 8, and those do in fact match. So we can factor out the y plus 8, which will leave y squared minus 1. And once again, we've got what's called a difference of squares right here that can be factored further, but I'm going to leave it alone for now. Let's do one more, and then we will stop this video, and I'll make a second video that shows some examples of what to do when you have a greatest common factor for all your terms, and you have to factor that out first, but we'll get to that in a minute. Here's one last one where we are going to group. All right, out of my first group, I see that I can take a 2 and also an a, which is going to leave me with b squared minus 3c. All right, my second group, I don't see a greatest common factor, so I'm going to just factor out a positive 1 because this first one's positive. Factoring out a positive 1 won't really change anything. Now I'm going to have b squared minus 3c, and if I factor that out, I'm left with 2a plus 1. Okay. Watch the next video for some more factoring by grouping examples.